Solving quadratics by using the quadratic formula. Today what we're going to look at is we're going to look at a different way of solving quadratics. So far you've learned about factoring. Another form you've used is completing the square. And now what we're going to use is the quadratic formula. Now the quadratic formula is uses the equation of a quadratic in standard form. It uses the coefficients a, b, and c to determine the solutions to a parabola. The quadratic formula is the opposite of b plus or minus the square root of b squared minus 4ac divided over 2a. Now you've had some experience in converting this form right here into vertex form, and then from vertex form finding the solutions using only variable coefficients. That is where the quadratic formula comes from, and that is how this formula is derived. Inside of this formula you'll notice that there is a square root symbol. It is the value of the number underneath the square root symbol that plays a critical role in determining the type and number of solutions that a parabola has. This value, b squared minus 4ac, is called the discriminant. The discriminant is used to determine the number and types of solutions that a quadratic form equation has. If the value of the discriminant is a positive number, you will have two real solutions. The graph of your parabola will look similar to this one, where it crosses the x-axis twice. If the value of the discriminant is equal to 0, it will have one real solution, and the graph of your parabola will look like this, where the parabola itself touches the x-axis in one place. If the value of the discriminant is negative, you'll have two imaginary solutions. Your answer will include I, and the graph of your function would look similar to this, where the parabola does not touch the x-axis. Now let's talk about the usefulness of the quadratic formula. A lot of people think the quadratic formula is a hindrance. It's actually not. The quadratic formula is the only form of, besides completing the square, the only form of solving quadratics that can be used every single time. You've come into some situations in the past where factoring wouldn't work. Well, now what we're looking at here is we're looking at a way to solve these problems all the time. And the quadratic formula is the way to do that. Completing the square is also, but since the quadratic formula is the general form of completing the square, we can just use that every single time as opposed to completing the square all the time. Alright, so getting into today's lesson, let's go ahead and take a look at this. We'll be going back and forth between the calculator, so it's going to be a good idea for you to have your calculator out. I'll be showing you some screenshots so you can see what's going on inside of your calculator. What are the values of a, b, and c? We're referring to the standard form of the quadratic, so that means a equals 1, b equals 10, and c equals 2. Calculate the discriminant and determine the number of solutions. Well, that's going to be b squared minus 4ac. Remember, you're not using variables when you're using the quadratic formula. You're only using the values of a, b, and c, which are the coefficients of each x squared and the x term and then the term by itself. So we get b squared, which is 100, minus 4 times 2 times 1. That is a positive 92. The value of this discriminant is positive, therefore there will be two real solutions. Now looking back on this, is this a factorable problem? Well, let's determine that. 2 times 1 is 2. Which two factors of 2 add up to 10? The answer is there aren't any. So this is not a factorable problem. Instead, we have to use a different means. and that different means is the quadratic formula. So it's the opposite of b plus or minus b squared, square root of b squared minus 4ac, all over 2a. I can hear the Addams Family song going right now in your head. The opposite of b, which is 10, plus or minus the square root of 100 minus 4 times 1, 2 times 1. We already know that to be 92. And that's going to be times 2a, which is 1. That simplifies down into negative 10 plus or minus the square root of 92 divided by 2. This breaks down into opposite of 10 plus or minus 2 times the square root of 23 divided by 2. That further simplifies because if these three numbers have a common factor, then we can divide out that common factor to all of them. They're all even numbers, so they will divide out. That becomes 5, negative 5, plus or minus the square root of 23. Remember, I got 2 times the square root of 23 by drawing my tree diagram. And that's how you did that problem. Alright. Oops, sorry. Told you I'd get some screenshots in here. So let's get the calculator up. Okay. The first screenshot is going to be showing you that because the discriminant is positive, the graph will touch in 2 distinct places. Number 2. A is 2, B is negative 1, C is 2. Let's look at it real quick. Oh no, let's calculate the discriminant instead. So that's going to be the opposite of b squared minus 4ac. So that's going to be negative 1 squared minus 4 times 2 times 2. So that's going to be 1 minus 16, which is negative 15. Now looking at the discriminant being a negative number, going back to this, what I was going to ask earlier is this factorable? The answer to that question is no. Again, looking at a times c, 2 times 2 is 4. What are the two numbers, what are the two factor pairs of 4 that add up to negative 1? And again, there aren't any. So we're going to have 2 imaginary solutions. Now because this is not factorable, we have to use a different means, and again we're going to use the quadratic formula. Opposite of b is going to be 1 plus or minus, now this time I'll just go ahead and simplify, negative 15 divided by 2 times 2, which is 4. At this point I've got to pull out that I, and the factor pairs for 15 are 3 and 5, so that does not simplify anymore. 1 plus or minus I times the square root of 15 divided by 4 is the solution to this problem. Alright, back to the calculator for a screenshot. I'll go ahead and switch from this one to the second one, and we'll look at the graph. You can see the parabola itself does not touch the x-axis anywhere along here, which does follow that pattern of no real solutions. Alright, example number 3. X squared minus 6x plus 9. So that's going to be 1 minus 6 plus 9. Okay? Now what we're going to do is calculate the discriminant. That's going to be the opposite, b squared minus 4ac. So that's going to be negative 6 squared minus 4 times 1 times 9. So that's 36 minus 36, which is 0. Now, is this factorable? The answer to that question is yes. What are the two factors of 9 that add up to -6? That's -3 and -3. But more importantly, this is a perfect square trinomial, which means the answer to this question is x. The factored form of this question is x minus 3 quantity squared, not cubed. Excuse me. But now let's use the quadratic formula to back up what we're talking about here when we solve this problem. So it's the opposite of b. That's 6 plus or minus the square root of 0. We'll just go ahead and simplify that, okay? Divided by 2 times a, which is 2. Well, that's going to be 6 over 2, which is 3. Again, we set this factor equal to 0, square root both sides. Then we get x minus 3 equals plus or minus the square root of 0. So it looks very similar to what we just did, but in a different way. Plus 3 to both sides. Remember, plus or minus 0 is redundant. X equals 3. So you can see how these coincide with one another as far as these are concerned. Our last and final screenshot, looking at number 3. And there is your graph touching the x-axis in one distinct place. So remember, the quadratic formula is useful all the time. Factoring only works part of the time. So you want to use, if you want to use a technique or a method that is going to give you the solution every single time for every single problem that you're using, the quadratic formula is that method.